So the topic of today's lesson is function of several variables. The basic idea, the basics of function of several variables. Okay. So here is the objective, here is the goal for today's lesson. Find a function value for a function of several variables and sketch the graph of two variables. Basic graph, how to plot the points, how to sketch the plane, those basic thing. And I think we will discuss about distance between, maybe I can add one more, distance between 2 points as well. Okay. And along the line, we'll talk about the equation of circle as well as equation of sphere as well, briefly, very briefly. Now, first of all, what is function of two or more variables? So the expression z equals fxy is the function of two variables if a unique value of z is obtained from each order pair of real numbers xy. Remember, in your calculus 1 and even in this course so far, what we learn is we learn a function of one variable, y equals f of x. Okay, y is called the dependent variable and x is called the independent variable. That's what we did. And in this lesson today, so we'll be talking about function of two variables. So we have two independent variable x and y, and z is the dependent variable. Okay, so that function of two variable and function of three variable. Let's say w is the function of x, y, and z, something like that. So that kind of function, function of two or more variables we'll be talking about. So for each x, you will get y here. In this case, for each x and y, you will get z, a unique z value. Again, in the function of one variable, this is a function of one variable. This is x is your dependent variable, independent, and y is called the dependent variable. We know that. In the same manner, if we are talking about function of two variable, this x and y are independent variable, and z is called the dependent variable. Okay, so now the question is, why do we need function of two or more variables? What is the application of it, right? So whatever we learn in this math, we want to look at the application. Can we apply this concept to solve real world problems, particularly from business and economics? That is the goal of this course. So what is the use of it? Is there any application of function of two or more variable in real life situation? The answer is yes. It has enormous application. It has, for example, most of the natural phenomenon, most of the real life situations involve two or more variables. Let us look at one simple example. Suppose you have an account in a bank. Okay, and if you put a deposit, some money into the account that pays some interest, then your amount that you get after a certain period of time depends on so many variables. For example, it depends on the money initial deposit that you put in. Okay, how much money you put at the beginning, what is the interest rate, and how many years that you want to put your money into the account. So even in this simple situation, there are three variables involved, and that will determine the amount that you will get after a certain number of years. Okay, so that means your amount is the function of initial deposit P, the interest rate R, and the year time. So that's function of PRT. Let's take one simple example. Let's say your grade in mathematics, okay, grade in this course. Your grade is the function of so many things. Maybe the quality of your instructor, right? The quality of your instructor, your health during the exam. If your health is good, obviously you do good. But during the exam, if you're not feeling well, then the chances are that you you will not do as good as you would like to do, right? Your health. I think in order to register for this course, you need to pay the money. Without paying money, I don't think they will allow you to enroll for this course. So first you need to register, which requires money. The amount of work that you put in, your efforts, okay, how much effort you put in. If you work hard, if you're working hard, maybe you can get a better grade. And you see, even in this simple case, there are so many variables involved. So therefore, what we can say is that in order to represent the real life situations, we need in general, we need um, more than one variable, right? So that's why it is important that we are trying to learn function of two or more variables and their derivative and their integration in this course. Now let's look at one simple example. The cost of renting a car depends on how many days you keep it and how far you drive. So represent this using a function. So it is a pretty simple situations, right? Let us suppose that D represent number of days and M represent number of miles driven. Then the function is, it will be then the cost of the car, then cost of the car is a function of day and number of days and number of miles. So it is a function of D and M, right? It is a function of two variables, D and M. And if we know some relationship between D and M here, then we can calculate the value. So let us look at example 2. And in example 2, we see that the relation between D and M is given, a function is given there, okay? The cost CDM in dollars for renting a car for D days and driving it M miles is given by the formula cost C represent cost, D and M equals 40D plus 0.15 M. Now in part A, what is the cost of renting a car for 3 days and driving it 200 miles? Well, we have the formula, so we know cost D and M equals 40D plus 0.15 M. So what is given here is given D equals 3 and M equals 200. So therefore, your cost 3 and 200 is going to be 40 times 3 plus 0.15 times 200, and that's going to give you, is that $150? right? That's it. Part B. I want you to try this part B just for fun. What is C 104? So remember, this is number of days is 100 and number of miles driven is 4. This one is a weird situation, right? The guy is actually renting the car for 100 days and all he drove is 4 miles. Okay, that's not good. But anyway, we can calculate what is the total cost. If you want to borrow the car, if you want to rent the car for 100 days, and if you just drive 4 miles, and the cost will be 40 times 100 plus 0.15 times 4, and that's gonna give you, I don't know how much is that, 175. No, 4,000 and 60 cents. Am I right? And now we need to calculate this, which is 40 times 4 plus 0.15 times 100 equals, you can calculate this. How much is this again? Am I right? And part C, suppose we rent the car for 3 days. Okay, in part C, given D equals 3, is C an increasing function of miles? So then your C, D is 3, M we don't know, that's gonna be 40, D is 3, and M we don't know, we just write M as it is. So that's gonna give me 120 plus 0.15 M. Is it increasing function or decreasing function? And why? Let me know. Think for a second and let me know whether it's increasing function or decreasing function. Okay, guys? You can write your answer in the chat box if you like. So clearly, C, this function C3M equals 120 plus 0.15 M is increasing because your slope equals 0.15, which is positive. And you know from your high school and also from calculus 1, when the slope is positive, then it's increasing, right? When the slope is positive, it's increasing. But when the slope is negative, this way, here slope is negative means it's decreasing. And in calculus 1, you learn that when the slope is positive, it means the derivative is positive. And when the slope is negative means the derivative is negative. When the derivative is positive, increasing, derivative is negative, decreasing. That's what we discuss in calculus 1, and yeah, that's it. Any questions so far? Let's try example 3 just for fun. The total cost to a company in thousands of dollars, the unit, pay attention to the unit, okay, is given by, what is given is C of X, Y, Z, W. It is function of 4 variables. which is given by 4x squared plus 5y plus z minus ln w plus 1, and where x represent the dollars for spent for labor, y represent the dollar spent for raw materials, z for advertising, and w for machinery. All you need to do is when x is 3, y is 2, z is 0, and w is 10, what is the value? Well, you just substitute it, right? X is 3 squared plus 5 times 2 plus z means 0 minus ln 10 plus 1. And I need your help. What do you get? So this one will be, I believe, 0. Like you said, 0 0.0436, 0.0436. But remember, the unit is in thousands, so this must $1,000. So if you want to change it into simple dollar amount, it's going to be multiply that by 1,000. So you're going to get $43.6. Okay, that's your answer. And I want you to try example 3 just for fun. 3 and 4. Okay, try that on your own. As the population of two cities grow, the number of telephone calls between the cities increases, much like the gravitational pull will increase between two growing objects in space. The average number of telephone calls per day between two cities is given by N of D, P1, population 1 of the first city, and P2 is the population of the second city, is given by the formula 2.8 P1 P2 over D raised to power 2.4. Okay, D raised to power 2.4. And so, and then what we are supposed to find is where D represent distance in miles between the cities P1 and P2 cities, and P1 and P2 are their populations. Suppose the city of Vancouver and Abbotsford are approximately 30 miles apart and have population of, this population is not the correct one. I just consider rough, just a random number. Okay, there may be the exact, it is not the exact number. I just wanted to tell you that. So N is, distance is 30, P1 is 1213825, and P2 is 624 and 067 equals, just substitute the value, you're going to get 2.8 times P1 is 1213825 times P2 is 624 067 over D is 30 raised to power 2.4. And if you calculate, what is the approximate value? Type in your answer in the chat box, please. Am I right? Yes, thank you. Now, notice that because we are talking about number of phone calls, if you get an answer, your answer is in decimal, that's not a good one. You need to round it up, because number of calls cannot be in fraction. You cannot say that, oh, I called you 4.2 times. Doesn't make sense, right? I call you like 7.8 times. Doesn't make sense. So pay attention to that. Even though the mathematical answer is correct, in decimal is correct, but since we are talking about the context or situation, then yeah, try to give the answer that fits to the situations. Okay. Example 4, a business purchase. If you have already got the answer for example 4, write that answer in the chat box. A business purchases a piece of storage equipment that costs C1 and has capacity B1. Later it wishes to replace the original with a new piece of equipment that costs C2 and has capacity B2. Industrial economists have found that in such cases, the cost of the new piece of equipment can be estimated by the function of 3 variables. Okay, so we are given a function or formula which is C2 equals V2 over V1 raised to power 0.6 C1. And what is given is, and also given is for $45,000. So that means the cost initial, I mean the C1, let us denote that C1. The cost, first cost is given, which is $45,000. And what else? What is given? And the tank has a capacity of 10,000. So initially the tank has a capacity of 10,000. So V1 is given. And so let us substitute the value. So we need to find C2, which is V2. Oh, V2 is not given clearly, but I believe you can find the V2 yourself, right? V2 is, later it decides to buy a tank with double the capacity. So that means B2 is actually 2 times B1, which means 20,000. So that's going to give you 20,000 over B1 is 10,000 raised to power 0.6, and C1 is 45,000. And that's going to give me, I don't know, how much is that? What is the answer? Did somebody calculated this already? Okay. 68207. Thank you, guys. So 68207.25. Because we are talking about the dollar amount. So yeah, this would be the answer. Any question?